On the journey to create a schedule, activities were defined, a network diagram was created, and durations were estimated. Next, the project team needs to find out the duration of the project and some other information. The method that is used to find the duration of the project is called the critical path method. The duration is the minimum information obtained by performing the critical path analysis. Let us run a scenario. Monday morning at 9 a.m., the manager asks the employee to have the weekly report ready by 5 p.m. The estimated time to write the report based on previous experience is 2 hours. When is the earliest the employee can start writing the report? 9 a.m. So if the employee starts at 9, the report will be completed at 11 a.m. because it takes 2 hours to write the report. What is the latest the employee has to start to complete the report by 5 p.m.? It will be 2 hours earlier at 3 p.m. So the employee will start at 3 p.m., work for 2 hours and complete the report at 5 p.m. 9 a.m. is the early start time and 3 p.m. is the late start time. Similarly, 11 a.m. is the early finish time and 5 p.m. is the late finish time. How many hours of difference is there between the early start and late start? 6 hours. So if the employee has a doctor's appointment, can go for 2 hours, on the way back, meets an old friend, goes for lunch together for an hour. Still 3 extra hours are available to complete the report, assuming there is no other work to be done on that day. Now, what if the manager at 9 a.m. asks that the report is to be completed by 11 a.m.? The early start is 9 a.m. and finish by 11 a.m. and the late start is also 9 a.m. to finish by 11 a.m. It means there is no extra time available. In this case, if the phone bell rings, the employee will not pick up the phone knowing that 10 minutes on the phone means 10 minutes late. In the first case, there was a float of 6 hours available, but in the second case, there was a float of 0 available, and this activity will be called critical activity. Any delay of the critical activity will cause the project to be late. The project manager needs to know which activities in the schedule are critical activities so that more attention is given to those activities to ensure these are not late. Critical path analysis helps us identify critical activities, recognize floats available to all the activities, and determine the duration of the project. If we assume that the report writing activity was just part of a schedule with many other activities, then in the first case, the activity can be started anytime between 9 a.m. and 3 p.m. and it will have no impact on the project or other constraints like a committed deliverable date. This float is called total float. But what if report writing is followed by another activity, report printing? If the report is completed at 11 a.m., printing can start at 11 a.m. But if the report is completed at 2 p.m., printing starts at 2 p.m. and so on. It means that even though the activity has a total float of 6 hours available, the free float is 0. Free float is the extra time available before an activity impacts the successor activity. The critical path will have a total float of 0, but not always. It can have a positive total float or a negative total float, but that will only happen when external constraints are applied. A positive float will be the extra time between early finish to the constraint that is set for a later date or time. So 6 hour float above will be a positive float, but the float can also be negative. For example, in the above case, second scenario, the manager asked for the report to be ready by 11 a.m. If the employee was late starting the report writing, say 10 a.m., there is a negative float of 1 hour. During project execution, negative float helps in identifying areas where schedule compression needs to be done, if possible of course, to bring the schedule back to track. Next, few other points about critical path. The critical path is the longest path from start to finish of the project. All activities on the critical path have a float of 0, at least when initially planned. There is always at least one critical path in a schedule, but there can be more than one path. The more critical paths there are, the more critical activities will be there in the schedule. The riskier the schedule becomes, or the lesser the chances that the project can be completed on time. So now, with all this background information, we will look at how to perform critical path analysis. There are 4 steps involved. First step, forward pass calculation. Second step, backward pass calculation. Third step, determine activities float. And fourth step, identify the critical path. The dependencies and the durations are shown in the diagram. The key is that early start will be on the top left of the node and early finish top right. Late start bottom left and late finish bottom right. The float will be bottom middle. The first step is to do the forward pass. Activities A, D and H are parallel activities that begin right after the start milestone. Since milestone has 0 duration, all these 3 activities will start at 0. We can call it end of day 0, which is the same as the start of day 1, since there is no work done between the end of a day and start of the next day. So the early start is 0. For activity A, add the duration of 2 days to early start 0. The early finish is 2, written on the top right side of node A. For D, 0 plus 5 days duration gives 5 as early finish, and for H, 2 as early finish. A finishes end of day 2, so B starts end of day 2. Now add the 3 days to make it 5, so B finishes at 5. E starts at 5 where D finished, the duration of E 3 days added, E finishes at 8. Now C cannot start until both E and B are complete. B is done end of day 5, but C has to wait for E to finish end of day 8. Thus earliest C can start is the end of day 8. Then add 4 days duration. The early finish of C is 12 days. Continue the same way, early start and early finish of F, G, I, J, they will be determined. What will be the early start of K? Well, C finishes end of 12th day. G finishes end of 8th day. And J finishes end of 10th day. So K starts end of 12th day. Add the duration of 2 days. The early finish of K is 14 days. Now the forward pass is complete, and it helped determine the duration of this project, which is 14 days. For the backward pass, we start from K and go back towards the start milestone. Copy finish milestone 14 days to the late finish of K. Subtract duration of 2 days and late start will be 12 days. C, G and J all will have the late finish as 12 days. For C, subtract duration of 4 days and the late start of C is 8 days. B and E both have a late finish of 8 days. For B, subtract 3 duration from 8 and the late start is 5, which is also the late finish of A. subtract 2 days duration of A and the late start of A is 3. For E, subtract 3 from 8 to get the late start of 5. And subtract 5 days duration of D from 5 to get the late start of 0. The same way, other activities late finish and late start can be calculated. So, at the end of the backward pass, we have determined the late start and late finish of all the activities. Next step is to calculate the float of each activity. For this, subtract early start from the late start and write that number, the float, in the bottom middle of the node. For A, 3 minus 0 gives 3 days float, and same for B. For D, 0 minus 0 gives 0 float. Same for E, C, K. Similarly, float can be calculated for rest of the activities. The fourth step is to determine the critical path. Which path from start to finish has all activities with a float of 0? Only one path. D, E, C, K. All 4 activities have a float of 0. So this is the critical path. A and B have 3 days float. It is the combined float of A and B. Do not read it as 3 plus 3. 3 days is the total float available for activity chain A and B. If A is late by 3 days, B will have a float of 0 and will become a critical activity. What if A is late by 4 days? Well, assuming all other activities are on time, the critical path will change and move to B, C, K. This is how critical path analysis is performed.